Assalamualaikum students. Welcome back to UTM. Virtually, you are in week 9. After 1 week mid-semester break, I hope you are rejuvenated to study harder. We are now in module 5 in digital logic. We have finished module 4 before the break. You learn about SOP for output 1, sum of product, and you learn about the opposite, which is post product of sum for output 0. You also learn how to do conversion between truth table to circuit to equation, and then what else do you learn? You learn about Boolean algebra, how to simplify it with the 12 rules. Is it 13? And then the not K-map. Before that, I always forget his name. The De Morgan's theorem, right? The physical circuit, then you have the logical equivalent to simplify. And then lastly, just before the break, you learn about how to use K-map to simplify your circuit. So let's begin with module 5. What you're going to learn is, right, the AND/OR and AND/OR invert logic. The most common way of drawing the circuit. So, and then we're going to continue to talk about the universal gate of NAND and NOR. Interestingly, you can actually draw a circuit using just one gate instead of many different gates. And lastly, alright, we are going to combine everything, and you will learn how to draw a circuit based on real life situation, real input, real output, by combining all the gates that you have learned. That's how we got combinational logic circuit. Let's start with basic combinational gates. What are they? We're going to start with AND/OR logic and AND/OR invert logic. In designing a circuit, we can make the output to become 0, which is a post expression, or output 1, active high, which is SOP expression. With active high, we can also use a rather standard implementation called AND/OR logic. Okay, how does a SOP expression looks like? So we have AB, alright, and then we have CD. Excuse my beautiful drawing. Alright, so this is AB plus CD, which is SOP expression. So we call it AND/OR because this is, you see N first, you see N first, and then you see OR. So we call it AND/OR logic. However, there are times where we want to get an active low output. So what we're going to do is we're just going to include invert. So let's see how it's done. So this is an AND/OR logic gate, So you have N here, and then you have OR. So that is how we get the name AND/OR logic. Let's look at one example here. How did I teach you before? So to use a SOP expression, AND/OR logic, alright, SOP expression for AND/OR logic, we search for output, active high output, which is all the ones. So the easiest way is to draw K-map. So normally, how do we do that? So we can write the Boolean expression. So either use Boolean algebra or K-map. Right, I don't have to teach this again. You just look at module 4 notes and from your book or the video, you know how to get CD and AB. Also, the slide also will show how to use Boolean algebra. Many steps to use Boolean algebra. So for me, I will just use K-map. Yeah, after all the steps, we get the same answer as K-map. So we have our sub-expression here. With the same truth table, there is the opposite, right? The post-expression. So this is the K-map drawing, right? With my with the grouping that I made. Please double check my work. I'll get this answer for the post-expression. The same truth table, that is my sub-expression, that is my post-expression. From our sub-expression, this is the drawing, right? A very distinctive shape. And or, right? How about our post-expression? So let me draw. For simplification, I just draw different input, a different wire for the same input. So then I combine everything to a, looks like a very huge AND gate. Yeah, so this is also our X. But this is OR AND. Because this is active low, yeah, not normally used a lot, so we don't call it OR AND logic. There is no OR AND logic, but there is an AND OR logic because it's a distinctive shape. So they are the same. Sub-expression, this is the gate. From the same truth table, we can also draw post-expression, right, post-expression, and this is the gate. Okay, from the same truth table. However, because the AND OR logic of the sub-expression is very distinctive, so there is a situation where our post-expression, we also want to draw it using AND OR logic. So I repeat, we want to draw our post-expression, yeah, not just the drawing from the previous slide. We don't want to draw OR first and then AND, but we want to, for our post-expression, we want to draw it just like our sub-expression, meaning we want to use AND OR logic. But we cannot use AND OR logic because AND OR logic is for sub-expression. Therefore, we will introduce invert here. We will introduce invert or not gate. So we call it AND OR invert logic for post-expression. So the drawing for post, no longer we draw OR, then AND, but we still use AND, then OR, but of course we must modify and include invert. So there are two ways we can draw post-expression. The normal post drawing, yeah, OR first and then AND. But there is a second way of drawing it using AND OR logic. By introducing invert, with post we draw AND OR invert logic. Okay, so how do we implement AND OR invert? So this is our output. Sub output, alright, which is AND OR. Okay. If we want to use post, which is n or invert. So what do? We add invert, right? We add that extra invert there. So this, let's say this is x. If this is x, now this becomes x bar. Yeah, this is the n or invert. So all the 0 become 1, all the 1 become 0. Okay, that is the first step. So we complement our output, become x bar, and we have the n or invert. So next, yeah, so this is our x, n or SOAP. We want to get our n or invert. N or invert here. We will, of course, yeah, because that is post, this is post, we will find the 0. We will draw K-map based on the 0 of the n or invert output. Yeah, so be careful, this is x bar. Not x, but x bar, and we draw the 0. So get the K-map, we will get this answer, which actually, remember our n or, our SOAP expression? So originally it was AB plus CD. This is x and using n or logic. When we want to have n or inverse logic, we have x bar. That means our AB plus CD now has a bar all over it. I want you to try this and solve this using De Morgan's. You will end up with this answer. Yeah? So again, I repeat, for SOAP expression, we have n or logic. So usually for post, still with the same output x, we draw K-map for 0 output for post. For SOAP and or logic, we draw the 1 output active high. But there is time when we want to draw post expression using n or. Of course, it's not possible. How can post using n or? So we need to modify n or, put it in verse. Yeah, we put it invert, so now it becomes n or invert for post. All right. So this is n or invert. Yeah. So this one n or. When you put invert, now it becomes n or invert. So you can. So how do you draw n or invert here? A and then CD, AB, CD, and then you just invert it. Put another invert of the bar. So now this becomes post. How do you know this is post? Because, hey, look, this is n or. But because we have that invert, now it becomes post. How can I prove it? I prove it by using De Morgan. So this is n or invert. Yeah, this is n or invert, which doesn't actually look like post. Yeah, this looks like SOAP. But actually, when you convert it to using De Morgan, look, you do get this is post. So I hope you understand. This is our original SOAP expression, a very distinctive shape. And OR logic. From the same truth table, this is our post expression. However, I've shown you, we can actually draw an easier circuit by using AND or invert logic for our post expression. Very easy. We just need to draw our SOP and then add invert. We get our AND or invert logic. Because sometimes it's easier and we want to represent post using AND or distinctive shape by introducing invert. Post AND or invert logic. SOP AND or logic. After you have understand the difference between AND or and or invert logic, between SOP and post, please try to answer this self-test. Implement the active flow output by applying the AND or invert logic using that truth table. We will continue in the next video for universal gate. Bye.